Good afternoon. It is day one of our lessons here in Honors Geometry. And we are going to start today with the building blocks of Honors Geometry. And particularly, we're going to start with something called undefined terms. So these are literally the building blocks, meaning they're undefined because we can't define them using other figures. This is literally where we're starting. We have to start somewhere, and we're going to start with these three undefined terms, which are point, line, and plane. So point, naming a location. Normally they are capital letters with a point somewhere around them, and we name them just like capital letters: point C, point D, point E. As you move on to lines, lines are a straight path, basically a double-sided arrow. They go on forever in two directions. And we can name lines a couple different ways. Typically, 90% of the time, we're going to name them with two letters, 2 points, with a double-sided arrow over the top of them. So like this could be line AB, or you could call it BA. The order does not matter in this scenario because we're talking about the exact same thing. It's going on forever in both directions. Occasionally, I'd say maybe 5% of the time, they will have this little cursive lowercase letter out here. It could be anything. This is L, and you could call this line L in that scenario. But typically that's not there. However, for Module 1, it does show up a little bit more often. Lastly, moving into planes. Planes are a flat surface. And of course, there's infinite amount of planes around you, but we name planes with 3 points that are on the plane. So like this plane ABC. Sometimes, again, occasionally, very rarely, you will have one of these little fancy sort of cursive capital letters like R. Notice there's no point attached to R, and you could name that plane R in that scenario. But typically, we name planes with 3 points on the plane. I'm going to give you a little extra tip here. We'll cover this later, but these 3 points right here need to be non-collinear point, and we'll talk about what that means here a little bit later. You want them to be non-collinear. Now, we've got those undefined terms. We can start to define things based on that. So we're going to talk about endpoint, rays, and line segment. So an endpoint is just a starting or stopping point. For instance, here you can see there's no arrows at A or B. Those are just two endpoints. Same thing here with F. It's an endpoint. There's no arrow going past F. And we would call those endpoints. So we can use that when we do something called a ray. So if a line goes forever in both directions, a ray extends in one direction. So in this case, we would say endpoint H here. We're starting at H, and we're going in I's direction, and we would call that ray HI, or more typically, we would write it like this, HI with a one-sided arrow over the top. So notation is going to be really, really important for us this year, so you want to make sure you're paying very close attention to how you notate it. Now, in a ray, the order of the letters really do matter, because I could not write IH, because that would mean that I started at I and went in H's direction, which doesn't exist here. So the order for rays definitely matters. Lines it does not, planes it does not, but rays it does. Lastly, a line segment, that's where you're going to have two endpoints. In this case, you're not going to have any arrows above it, and you're just going to call that line segment AB or line segment BA. They are the exact same. The order there does not matter. So let's do a few examples with this. We're going to practice a few of these together. So first one, draw a plane and label 3 points in the plane. Okay, so a plane is a flat surface. Typically we draw these as like little parallelograms just to give it sort of a three-dimensional look to it. But you can just draw a rectangle if you'd like. And I'm going to put 3 points on there. We'll stick to the basics, A, B, and C. And it says name the plane in 2 ways. Now I told you the order doesn't really matter here. So we're going to call it plane ABC for starters. And we'll just reverse those letters. We'll say plane CBA for a second version. How many points to use to name a plane? We've talked about this in that first definition. You need 3 points. They should be non-collinear, which we'll talk about here in a second. And then, does the order of the points matter? No. They do not matter, as you can see here. Just make sure that you write the word plane in front of it. Otherwise, if you just write ABC, we may think you're talking about points ABC. As for B, let's change up colors here. B, we want to draw a ray with P as an endpoint. So there's P. I'm going to go out here to the right. It's a little bit too far. There we go. I'm going to put another point on there, maybe PQ. Write a name for that ray. That would mean start at P, go in Q's direction. Does the order of the points matter here? Yes, indeed, the order does matter. Because again, in an array, you have an endpoint and then you have a direction you're going. So in this case, we're going in Q's direction. On to letter C, draw a line segment. So a line segment and array that lie on the same line. So here's what we're going to do. We're going to draw a segment first. I'm going to stick to pretty easy letters. A, we'll call this second one B. And then because we also want to draw an array, I'm just going to actually just keep extending that line a bit. So we have segment AB, or you could call it BA if you'd like. But you also have array there, meaning starting A and go in B's direction. And again, order matters, so I couldn't name that BA or ray BA. It has to be AB only. Now, I told you a couple times that when we name planes, we name them with non-collinear points, and there's a reason for that. So let's talk about what collinear means. Collinear means just on the same line. So points that lie on the same line, K, L, M, they're on the same line. Those are collinear. K, L, N, non-collinear. They're not on the same line. Same with coplanar. This is also another word you can put in your vocabulary. Coplanar, points that lie on the same plane. But you could also throw a non in front of these and say non-coplanar or non-collinear. And here's the reason why we want to name planes with 3 non-collinear points. And again, I'm going back to this definition here where I said don't want to erase it, where I said non-collinear here. The reason we want them to be non-collinear is because if they are collinear, we could actually push several planes through, and it would be really hard for me to demonstrate that on this paper. But just imagine 3 points. If you drew 3 points in a line on the piece of paper in front of you, not only are they on that piece of paper, but I could also drop a piece of paper vertically that goes through those 3 points. And now you have 2 planes that cross through the same 3 points. And of course, that would be 2 different planes. So we want to name them non-collinear. That way we're only naming 1 plane and 1 plane only. I'll use this picture as an example to kind of finish my thought on that. So like B, C, and D, those 3 points are collinear. Not only are they on the blue plane, but they're also on the orange plane. So if you named that plane B, C, D, I wouldn't know what plane you were talking about, which is why we want to use non-collinear. So for number 1, I think we just kind of answered that question. Use the figure name each of the following 3 collinear points. That would be B, C, and D for this picture. If we were naming 2 lines, remember lines go on forever in both directions. We could call AC a line with the double-sided arrow. We could also do BC. By the way, you could also call a line BC, BD. You could call it DC. You could call it DB. A lot of different ways you could name that other line on that figure. And lastly, 2 planes. I'm going to use the 3-letter example for the plane. So naming the blue plane, I would call that plane ABC. Again, order doesn't really matter there. You could go CBA, BCA. Just make sure they are non-collinear when you name these planes. And let's do the orange plane. The orange plane we could name as plane, let's say BCE. Oh, don't really need the commas there to name a plane. BCE. There we go. Lastly, down here, now we're going to draw our own figures here. Draw and label the following: a segment with endpoints M and N. So I'm going to start with 2 dots, M, N. There's a good picture of a segment. Stops at both my endpoints. We would label that as MN or NM. Either way, doesn't matter. We're talking about the exact same thing. For number 5, when we name array, now the order here is going to be important. We want to start at F. And we're going to go in G's direction. So we have to name that one FG, 1-sided arrow for array. Lastly, number 6, this one's going to take some thinking. Draw and label opposite rays with common endpoint Q. So opposite rays mean we're going to have rays going in opposite directions. They're going to share endpoint Q. I'm going to throw 2 more points on here to make 2 separate rays. And we've got ray QP, starts at Q, goes in P's direction. And we also have QR, starts at Q, goes in R's direction. So we've got opposite rays there, and they share endpoint Q. They both start at Q. Lastly, here are some what we call postulates. We'll get into this a little bit more tomorrow, but just some basic ideas about how these things interact with each other. For instance, most of these are common sense. Through any 2 points, there's exactly one line. So that would be the only line you could draw that goes through both those points. Here's through any 3 non-collinear points, there's exactly one plane. I'm going to point out that word exactly one. That's what I've been talking about this whole time with those 3 non-collinear points. If they're collinear, you could name more than one plane, and we don't want to do that. Number 3, if 2 points lie on a plane, then the line containing those points lies in the plane. Seems pretty simple. Number 4, if 2 lines intersect, then they intersect at exactly one point. So if I drew 2 lines here, there's 1, there's 2, they intersect at one spot and one spot only. Lastly, if 2 planes intersect, and again, this is a tough one to model, but if 2 planes intersect, then they intersect in exactly one line. Think about the walls in your room coming together. When they intersect, when those 2 walls meet, they form a line. I actually just showed you a picture of this same exact thing. You can see here in this picture, when the blue plane and the orange plane come together, they are crossing at a line. Okay. And so that would finish the lesson for today. We are going to do an activity in class, modeling points, lines, and planes. Feel free to find it on Google Classroom and do the modeling activity yourself. And that is part 1